okay, what is the math? What's the nitty-gritty, nuts and bolts, looking up stuff, doing calculations part? This has been de-emphasized in the AP test, but still something that you're expected to be able to do. So if I want to find delta G for a reaction, I have essentially two different ways to do it. There are actually more, which we'll talk about later, but at this point you have two ways you could find delta G for a reaction. One would be find delta H naught and delta S naught. Then use delta G naught equals delta H naught minus T delta S naught. Right, so if you want to know delta G for a reaction, one way to do it is find delta H and delta S. And then just use this equation at whatever temperature you're talking about. Pretty straightforward. The other way is, well, just like heat of formation, so I'm glad you guys gave me the segue back to heat of formation. Just like delta H of formation, there's a corresponding number called delta G of formation, which has also been measured for pretty much everything out there. So when you look things up in the table in the back of the book, it'll list delta H of formation, it'll list standard entropy, and it'll list delta G of formation. So the second way would be look up delta G of formation values, and then you use pretty much the same equation as we said for delta H and delta S. This is also on your formula sheet. What does this symbol here mean, this sigma? What does it stand for? The sum of. So the sum of the delta G of formation of the products minus the sum of the delta G of formation of the reactants. So on the next slide, you have a reaction between methanol, very poisonous, and carbon monoxide, also very poisonous, to make vinegar. Not so poisonous. Tasty. All right, so use the book, find delta H naught, delta S naught, and delta G naught for this reaction at 25 degrees Celsius. What is the question is, what does the naught stand for? The naught is that superscript there, means at standard conditions. Yeah. Yeah. All right, go for it. All right. So I think you can see this part not as fun and expansive as the conceptual part. A lot more tedium. Looking stuff up, doing math. I looked them up and I put them in a table here for myself. And then I went and did my calculations. I hope I did them correctly. But for delta H and delta S, I just did products minus reactants. A key distinction is the units. Always include your units. Delta H and delta G are usually in kilojoules. Delta S is usually in joules. Delta G, you can find in two different ways. You could find it using delta H minus T delta S. Or you could do products minus reactants, assuming you have it. Those two numbers should agree. I guess the one thing I left out of my calculation here is that this would be 1 kilojoule per 1,000 joules. So you'd have to divide that part by 1,000. So on the problem set, you'll get some practice with this. But this is the boring part of thermodynamics. I like the conceptual part. Hopefully you will too. Problem set do is